To perform subtraction in bases other than 10, we're going to make that same addition table that we did for performing addition in bases other than 10. So let's revisit base 5. And our base 5 addition table. Now remember that addition is the inverse of subtraction, which means we can use this same table to answer subtraction problems. What I'm saying is, from this table, I can read that 4 plus 3 is equal to 12. And I can write that, not 12, that's 1, 2, base 5. And I can write that as 4 plus 3 equals 1, 2, base 5. Because I know this, I can write two corresponding subtraction problems. I can write that 1, 2, base 5 minus 4 equals 3. Or I could write 1, 2, base 5 minus 3 equals 4. So what I can do is make this table, which was intended for addition, I can make it work for subtraction just by rewriting an addition problem as a subtraction problem that's related. Now we're going to keep working in base 5 here, and I want to do some subtraction problems in base 5 to demonstrate how it works. So if we're looking at the number 3, 4, 3 in base 5, I can represent that using tally marks, but I'm going to warn you that it's a little bit overwhelming. I'm going to do it anyways, but be prepared. So 3 in the ones place looks like 3 tally marks. 4 in the group of 5 place looks like 4 of these groups of 5. And then 3 in this third place value, that looks like the base 5 squared. That's saying 5 groups of 5. That looks like this. This is 5 of the 5 groups of 5. I need 3 of those. Okay, that's 2. I need 1 more. All right, so I have 3 of the 5 groups of 5. I have 4 of the 5 groups of 5, and I have 3 singles. So that's our number, 3, 4, 3, base 5. I want to subtract 2 units. So for that problem, all I would do is take 2 of the single units away, and I would be done. So I would just cross off 2 of those. That would take my number. It wouldn't change any of the place values above that. It wouldn't change them at all. Just changes the ones place. I still have 3 of the 5 groups of 5. I still have 4 of the groups of 5, and then I have 1 single. So my answer would be 3, 4, 1, base 5. I could write this as a missing addend problem by saying 2, base 5, plus something gives me the number 3, 4, 3, base 5. This 2 plus some number, some digit in base 5, has to give me the 3 in the ones place. So I can go to my addition table and look at all of the numbers that I could possibly get when adding 2 to another digit. Notice I want a 3, so the only possibility would be if I added 1. So 2 plus 1 gives me that 3 that I want. And then if I'm going to have 3, 4, and I'm adding zeros over here, then this number would have to have those 3 4s as well. So the missing addend will get me the same answer as that subtraction I did. So we did this in a couple different ways. We did the concrete model using tally marks. We did the standard algorithm over here doing the subtraction, and then I did a missing addend model to find the same answer no matter which way we solved it. Let's try another problem. We have 2, 2, 2, base 5, and we're subtracting 4, 3, base 5. Now we could do the concrete model, and I encourage you to try that, but I'm going to show you how to do this using a missing addend model using the lattice algorithm. So the number we're looking for goes down here, and if we were able to add that number to this 4, 3, base 5 number, that sum would need to be equal to the 2, 2, 2, base 5. So if we do the lattice algorithm, we're looking for the digits of the number that I'm going to add to 4, 3, so that when we complete our lattice, after adding down the diagonals, we get the number 2, 2, 2. So we need some number in the ones place to add to the digit 3 so that we get a 2 in the singles place of this place value box. So let's look in our column or row of 3. The only option in that row that has a 2 in the ones place is 3 plus 4. So that first digit has to be a 4. If we add 4 plus 3, we can fill in those numbers. We have 2 units and 1 group of 5. Then we can move on to the next place value. Looking in the next place value, we need a digit that when we add to 4, we put the digits in this place value box, and when we add down the diagonal, 1 plus whatever number goes in this ones place gives me a 2. So let's look at our row of 4. We have a number that ends in 4, that won't work. A number that ends in 0, that won't work. A number that ends in 1, that could work. Because if I put 1, 1 right here, then I would have 1 plus 1 to give me this 2. So that's a possibility. What if we had put 1, 2 in that box? Well, if we had picked 1, 2, then we'd have 1 plus 2, that would have to be 3. So we know 1, 2 won't work. What about 1, 3? Well, 1 plus 3 would be 4. We need it to be 2. So we know 1, 3 won't work. The only option would be 4 plus 2. So we can put 2 in this box. 2 plus 4 is the number 1, 1. And yes, when we add down the diagonal, we get the appropriate 2. And then we move on to our next place value. This place value box is adding to nothing. But when we add it, we need our ones digit plus the ones carrying over to add to 2. And I also know that I need a 0 up here because we don't have any numbers further on down the place value list. So the only option would be 1, because 1 is the only number plus 0. That gives me 0, 1. Adding 1 plus 1 gives me the 2 I need. Now remember, this top number is the number we were looking for. So our answer should be 1, 2, 4, base 5. Now, if we wanted to do this using the standard algorithm, we can, but let me warn you, it can feel a bit magical, not necessarily in a good way. If I have 2 and I want to take 3 away, I say I can't. So I go to my neighbor and I borrow. So when I reduce that to a 1 and I carry the 1, it now looks like 1, 2 minus 3. To read this table for subtraction, remember we're going to relate that subtraction problem to a corresponding addition problem. So if I'm doing 1, 2 minus 3 in base 5, I need to relate the number 3 and the number 1, 2. And they are related by the number 4, which means 1, 2 minus 3 equals 4. Then I can move on to the next place value. Unfortunately, that one requires us to borrow as well because we have 1 minus 4. So we have to regroup, going over to the next place value, reducing that by 1, and then regrouping so that in my group of 5 place value, I now have 1, 1 minus 4. To find that subtraction problem answer using our addition, we come to our 4 column and we look for how 4 is related to 1, 1. It's related by 2, which means 1, 1 minus 4 equals 2. And then lastly, we bring down the 1. We get the same answer, 1, 2, 4, base 5. Now, I'll admit, both of these feel a little bit wonky, but that might explain why a lot of people have trouble with subtraction, even though they understand the concept. Carrying it out can feel a little bit confusing, and that's because of this regrouping requirement when we're subtracting numbers that require regrouping. Let's try our equal addends process to see if we can do equal addends to make this subtraction easier. Now remember that equal addends will allow us to subtract without having any borrowing necessary. So the first step would be we need to find a number that when we add it to our 4, 3 number, it puts a 0 in the ones place. So looking at the 3 in the ones place, I need to pick a number that when I add it to 3, it will give me a 0. So here's my 3 column. The only choice I have is 3 plus 2. So I'm going to add 2 to both numbers. That's going to give me the new problem that says 5, 0, base 5, because 4, 3 plus 2 looks like 5, 0. And then 2, 2, 2 plus another 2, that turns into 2, 2, 4, base 5. And now I can do my subtraction. Well, that still requires borrowing, so maybe we need to add some more. If I wanted to turn, oh, I just made a common mistake that we're all going to make. So be prepared for that. I just put 4, 3 plus 2 equals 5. And that's a big no-no because you can't write the digit 5 in base 5. Remember that 4, 3 plus 2 would look like 4 groups of 5 plus 3 units, and then I'm adding another 2 to that. But those can be turned into a group of 5. But once I add that group of 5, I now have 5 groups of 5. So that actually looks like the number 100, base 5. So when I added 2 to 4, 3, base 5, that actually turned into 100, base 5. And now we can do our subtraction without any kind of regrouping. 4 minus 0 is 4. 2 minus 0 is 2. 2 minus 1 is 1. So again, same math problem, same answer, but a different way to get there.